Good morning. Welcome to our channel. Today we are going to discuss about image segmentation. So the content present in this slide was prepared by Dr. Mai, and this is as per the syllabus of the subject code, which is nothing but EE4H MSc 0407191 of the Birmingham University. So for more details, you can check that website. So I am here just to explain the concept of the image segmentation. So what's meant by image segmentation? What is the purpose of image segmentation? Why we are going for image segmentation? So what is meant by segment? To divide. Segment is nothing but divide. So you consider just you are going to make some division in an image. As like you are consider you are going to segment a cake, you are going to cut that cake into some roughly 4 to 5 slices. So at the end, you will be getting 5 pieces of cake. The same way, consider an image. So you are capturing a photo through your mobile. So that's an image. So that image, you are going to do segmentation. So what's the purpose of doing segmentation here? So when you do segmentation, there might be some object present in your image. So those objects will be highlighted when you do the segmentation. For example, you are capturing your college bus. In front of the bus, 2 students are standing. So when you capture that image, so what happens means that two, two persons will be extracted separately, and the bus object also, it will be extracted separately. So when you pass it on to the machine learning model, so finally you will tell that the object present in the bus are the object present in the photo is bus and 2 students. So that's the purpose of image segmentation. Easily you can extract the object present in the image. So how they are doing segmentation means how they are finding segmentation, how they are finding the object. So there will be some changes in the pixel when an object is present on the image. So you consider a football is present in an image. So adjacent area will have different pixel. The exact location where the football is present has some various pixel numbers. So in that way, the system will easily identify the presence of an object in the image. So the segmentation is based on the gray level, color, texture, depth or motion. Okay. So another application of segmentation is consider you want to analyze the given input image. So for analyzing a given input image, the first step is image segmentation. Because when you do image segmentation, you can easily understand the object present in the image, and easily you can understand the entire thing about the entire technical details about the image. So you can find the objects present in the image. You consider that some medical application. You consider the input is a brain image which is affected with a tumor. So usually what will be our application? We have to find the location of the tumor. So in that case, we need to analyze the image. So the first step which is used to locate the tumor is image segmentation. So when you come for the various applications of image segmentation, so image segmentation has a huge application in the general day-to-day life as well as in medical images. So in medical images, as I told earlier, location of tumor and identification of tumor plays an important role. Okay, next you consider the satellite image. So when you identify a satellite image, so from the satellite point of view, you can analyze your city. So when you just consider some particular area, so you are going to analyze how many buildings are there. So in that time, you can take the satellite image, you can identify the size and the shape of the buildings, roads, everything. And based upon the segmentation, you can do some compression or whatever applications you want to do, you can do the segmentation. And there is another thing like object identification. So object identification, you can consider there is a natural disaster has happened, an earthquake has occurred, so buildings will be collapsed. You consider some random person, so some random person is present inside the building collapses. So in that case, you need to identify that person. So you can send a robot. So the robot will be checking each and every object present in the hidden collapsed building. So when it identifies a person exactly, it can give the information to us that here is the person whom we are looking for. Okay. Next, we can see one example. A grayscale image is there on the left side. There are some mixed of vegetables are there. So how to know how many types of vegetables are there? So when you do the segmentation, it will highlight the each and every vegetable exactly. It will give a different color shades to the each and every object. And then we can proceed for the object labeling. So it will give label for each and every object. A second example, segmentation based on texture. So here you can see it's a normal room. So in that room, you have two set of sofas and tables. So based on the textures, image segmentation can identify the presence of sofas in a room. Consider you are a military people is checking, they want to check inside the house whether a terrorist is present there or not. So if they have this image, they can easily understand what is present inside the room. What are the things present inside the room? So when they have the image, they will have a clear picture that these objects are there. So a human can hide behind these objects. So texture segmentation. Next thing is motion segmentation. So here you can see there is a motion. So whenever there is a motion, the optical flow, there will be a change in the optical flow. So in that way, that optical flow will be detected. So where is the application of this optical flow is nothing but when you just check the city roads and you consider 10 cars are flowing in. So when you check the optical flow, you can easily able to count that there are 10 cars in this road, which is in moving direction. So object counted can be done using that optical flow. Now you can see another input image. So left side it is having input image. So two categories are there. We are just preparing the range image from them. Then finally the segmented image. So the difference between the range image and segmented image is range image will be grayscale image, whereas segmented image will be binary image. So binaries are nothing but zeros and ones. So objects present in the image will appear as one, means white in color. Objects, if there are no objects, it will be black in color, which is indicated by the number 0. So now you are seeing gray level histogram based segmentation. The segmentation we can do in various ways. So earlier we have seen the segmentation based on the texture. Now we are going to see gray level histogram based segmentation. What's meant by histogram? So histogram denotes the intensity of the given image. So based upon the intensity, we are going to do image segmentation. So to do this operation, there are two types, namely two popular techniques, namely thresholding and clustering. So now we are going to see these operations, namely thresholding and clustering. So you consider a zero, low, and high noise level image. So the same object, first image does not has any noise, second has low noise, and third one has high noise. Okay. So now we are going to do the segmentation. So to do that segmentation, we have to take the histogram of each image. So noise free image, you can see it's simply two spikes at I equal to 100 and I equal to 150. So low noise means there are two clear peaks. Here you can see the image graph, noise free, low noise, high noise. So low noise. Low noise is nothing but you can see two spikes at I equal to 100 and noise free is gray color, 100 and 150. So low noise is nothing but two clear peaks are there the same way. The high noise, there is a single peak. So high noise, you can see it is denoted in blue color. So it's just keep on increasing and it has a single peak. Whereas low noise also has two peaks. So this is a histogram of an image. When you plot an histogram, you will get like this only. It will just mention the image intensities. So in x-axis, it is nothing but it denotes the pixels. So pixels ranges from 0 to 256. In y-axis, it denotes the number of elements. For example, you consider we are having the pixel value 100. How many times? You can consider this region as some 850. So there are 850 elements with pixel value 100. So you can conclude this. The corresponding y-axis value roughly consider 850. So you can consider as there are 850 elements, the pixel value 100. Okay, so to analyze the property of that output image, you need to find signal to noise ratio. So which is denoted as SNR. So S slash N equal to, you can see it is mu B minus mu naught by sigma. So for our images, the noise free will be infinity and the low noise will be 5. High noise means 2. Okay, so now you can see there is a clear valley between the two peaks. So these are the two peaks. Consider the red image. So there are two peaks and this is a valley. So there is a clear valley between the two images, two peaks, object and the background. So there is an image. In that image, you consider a football is there and in background just a plain grass. So when you take the histogram equalization, when you find the histogram value, when you plot the histogram, the object will show one peak, the background will be in another peak. Okay, now we have to check the condition. So if the consider pixel P is the background pixel. So if the pixel P is less than T, then pixel P is an object pixel. So you consider T is nothing but threshold. So we have set some threshold value. Earlier I told that the pixel value ranges from 0 to 256. So you consider I'm setting capital T value as 200. So how you are finding whether there is any object or not? So you have to check the condition whether the pixel value is less than the threshold value, then it is considered as an object. So in this way, we have to find the threshold based segmentation. Next, I told the threshold value we have mentioned as 200 for example. How we have to decide that threshold value? So there are many techniques to decide the threshold value, namely interactive threshold, adaptive threshold, minimization method. Okay, now we are going to see the minimization method for determining the threshold. So there are three types in threshold to find the threshold value: interactive threshold, adaptive threshold, minimization method. So minimization method. So for minimization method, we are referring the content given by Robot Vision, Haralick and Shapiro, and the journal volume number is 1 with the page number 20. So you can see this image already we have seen the histogram with two peak values and a single value. So any threshold which separates the histogram into two groups. Okay, so here we have two groups. One peak, two peak value, so two groups. Any threshold separates histogram into two groups. So we have to find the homogeneity of each group. And each group will be having separate mean and separate variance. So the optimum threshold, the best threshold is that threshold which minimizes the within group variance and maximizing the homogeneity of the group. So how they are finding the threshold? It should maximize the homogeneity of the each group. So you consider the threshold value is capital T and O is the object, background is B. So they are finding using the probability. The prior probability of group O object is P0 of T. The prior probability of group is PB of T. So here the group object pixel value should be less than capital threshold and the background should be greater than threshold. So based upon these probability equations, we can derive like P of P0 of T equal to summation from I equal to 0 to T, P of I. Then for background, it should be I equal to T plus 1 to 255. Then finally, P of I equal to H of I by N, where H indicates the histogram of an N pixel image. So next, they are finding the mean and variance. So mean is indicated as mu and variance as sigma. So we are finding the mean and variance for the object as well as the background. Then based upon that, we are calculating the variance equation and at last we are finding the threshold value. So now you can see T opt. So T opt indicates the threshold value. So based upon this threshold value, we can do the segmentation. So low noise image. Here we are doing threshold based threshold values 124. How we are setting that 124? Using there are three types to determine the threshold value, namely interactive threshold, adaptive threshold, and minimization method. As now we are explaining only the minimization method. So based upon the minimization method, the threshold value is found as T equal to 124. Now you are checking the segmentation of low noise image. Okay, so next is gray level thresholding of high level of pixel misclassification noticeable. So the extent of pixel misclassification is determined by overlap between object and background histogram. So sometime I told a football image is present on the grass image. So in background is grass and football is a object. In some place, the football image will be merged with the grass image. So there you can see object and background. So two peaks are there. There is a single valley. Here they are just integrating, they are closing that valley with they are interconnecting the two peaks. So when you interconnect it, it is nothing but it is filling that overlap region. So for greater histogram overlap, the pixel misclassification is obviously greater. So in that overlap region, misclassification will be more. So here you consider a normal object and the background image. Okay, so till now we have seen the threshold based segmentation. Now we are going to see the clustering. So clustering, it tries to separate the histogram into two groups. Consider a class of 20 students which has 10 girls and 10 boys. So clustering will divide them into two groups, one group with boys, one group with girls. So the first group you consider C1, second group C2. So gray levels classified according to the nearest cluster center. So then we have to apply the concept of nearest neighbor clustering algorithm. And the most popular clustering algorithm is K-means clustering. So it is a simple iterative algorithm. So here you can see the given set of gray levels, which is indicated as G1, G2 to G of n. And we are partitioning this one as G1 and G2. So G1 of 1, G1 of 2, till it goes on like G1 of n1. Next, G2 of 1, G2 of 2, it goes to G2 of n2. Next, our objective is we have to find the means of each group. So this is a formula to find the mean. So already we have two groups, namely C1 and C2. So we have to find the mean of C1 and C2. Next, we have to redefine that new groupings. Or you can say like all gray levels in set 1 are nearer to cluster center C1 and all gray levels in set 2 are near to C2. Okay. So your objective is we have to find the mean. And the next objective is we have to define an iterative algorithm. So we have to define the iterative algorithm. So here we are seeing the iterative algorithm. Iteration, what is meant by iteration? We have to repeat the actions continuously. So initially we have to label each and every pixel. Then we have to find the mean value C1 and C2. Then we have to do the partition. So till how much time we have to do partition means until no pixel labeling changes. So we are doing iteration there. And the problems what we get. I mean, two questions may arise here, whether this algorithm converges. If it gets converged, what does it converge exactly? So here we can prove that the algorithm is guaranteed to converge and it provides a good sensible result. So now we are finding the proof of algorithm convergence. So you consider an cost function P of R equal to, we are adding two things here with respect to group 1 and group 2. Next, we are updating the cluster center C1 and C2. Finally, we are just adding both the centers. So you can see here, E of R plus 1 is less than E1 of R, which is less than E of R. It means we are proving that E of R is greater than 0. So we conclude that algorithm must converge. So now we are going to see how it is. So it is converged to which? E1. So here you can see E1. E1 is nothing but updating the cost function. So that E1 is nothing but sum of variances within each cluster. So E1 is nothing but sum of variance of each cluster C1 and C2. Here you can see two groups, object and background. Two cluster centers are there and two groups sub-partitioned into G1 and G2. All the segmentation algorithms we have considered thus far have been on the histogram of the image. So you can see all the examples we have seen based upon the histogram of the graph image. So whenever there is an object, we will be getting a continuous set of pixels. So here you can see the one image background you can see with the gray color, and there is an object. That object is highlighted in black color. So we are going to see some relaxation labeling. So labeling, we have to label all the pixels. So consider an image where probability P of I. So I is nothing but background pixel. 1 minus P of I will gives you the object pixel. So consider the 8 neighborhood starting from I1 to I8. Next, we have to define the consistencies CS and CD. So here we are assuming again a bimodal image, bimodal object slash background histogram with maximum gray level G max. So usually G max will be around 256. Then we have to initialize the probability as G of I by G of G max. Okay, so now you can see the neighboring probabilities P of I1 comma P of I2 and 2 into P of I8. So these things are nothing but the relaxation labeling. So labeling is just to mention some, assign some values to the pixels. Okay, so now we are going to perform these things with the high noise image. So you can see the high noise circle image, optimum threshold value, and we are applying the relaxation labeling. The number of iterations is 20. Next, we are applying the same concept to the clamp image. So left side is the clamp image original, and the next image is a noise added. And finally, we are getting a segmented clamp image, number of iterations equal to 10. So the same thing we are applying to another popular image named Lina image. So original, then the number of iterations is 2. Number of iterations is increased as 5. The number of iterations is increased to 10. So then you are taking the histogram for these three images, 2 iteration, 5 iteration, 10 iteration, and for original also. So totally we will be having 4 histograms. So you can see in the legend box here, original is highlighted, the 2 iterations, 5 iteration, 10 iteration. You can see the corresponding graphs here. Okay, next follows the expectation maximization algorithm. So we are using this for the relaxation labeling. So here you can see a pyramid image. You consider with 4 sides and at last the center of the object. So theta 1, theta 2, theta 3, theta 4 are the 4 sides. And the center of the object is circled as theta 5. Okay, so this is the EM algorithm, which is nothing but the expectation maximization algorithm. So sometimes for image segmentation, we can use this EM algorithm. So you can see here, a recent approach to apply EM to image segmentation is to assume the image pixels or feature vectors follow a mixture model. So usually you can see a Gaussian mixture model will be used. So this type of segmentation, this expectation maximization algorithm is used to segment the image. So in that what they are doing is nothing but they are applying the extraction of the feature vectors following a mixture model. So when you apply that one, you will be getting the segmented image. So these are the some mathematical operation for the EM algorithm. So we have seen four types of segmentation, namely thresholding, clustering, relaxation labeling, and the EM algorithm. In that, thresholding is more popular. In clustering, the popular thing is k-means algorithm. So remaining two algorithms are very, very rarely used, as we have seen the introduction of latest segmentation algorithm. So thresholding and clustering are more popular among these four types. So this is the content of the image segmentation syllabus present in the Birmingham University. So in the next session, we will discuss about the image segmentation prepared for other universities. So we are discussing only the topics, syllabuses, which is popular, which is present in some popular universities.